The efficiency condition for providing public goods that we first hinted at in graph 27.1 can be derived more formally using individual indifference curves and considering the trade-off between private and public goods. We begin with what's called a production possibilities frontier that illustrates the trade-off between private consumption and public goods production. We'll assume that individual 1 is endowed with the private good level E1 and individual 2 is endowed with the private good level E2. If no public goods are produced, then the highest possible private good consumption on the vertical axis is E1 plus E2. As public goods are produced, private consumption has to decrease because it takes private goods to produce public goods. And if the marginal cost of producing public goods is increasing, then it takes an increasing amount of private goods to produce additional public goods as more public goods are produced. For any public good level on the horizontal axis, the slope of the production possibility frontier indicates how much in private goods we have to give up on the vertical axis to get one more unit of the public good on the horizontal axis. In other words, the absolute value of the slope of the production possibility frontier is the marginal cost of producing an additional unit of the public good in terms of private goods. With the shape of the production possibility frontier that we've drawn here, the slope is increasing in absolute value as more public goods are produced, indicating that the marginal cost of producing public goods is increasing as more public goods are being produced. In panel B, we introduce an arbitrarily drawn indifference curve for individual 2, and we'll imagine that our goal is to ensure that individual 2 attains the utility level U2 bar that's associated with that indifference curve. The slope of an indifference curve, or the marginal rate of substitution, is always the amount the individual would be willing to give up of the good on the vertical axis to get one more unit of the good on the horizontal axis. In our case, for any public good level on the horizontal axis, the slope of the indifference curve is the amount the individual would be willing to give up of the private good in order to get one more unit of the public good. Or put differently, the absolute value of the slope is the marginal benefit the individual would receive from one more unit of the public good in terms of private goods. One way that we could ensure that individual 2 attains the magenta utility level U2 bar is to provide the individual with the public good level that occurs at the intersection of the magenta indifference curve and the green production possibility frontier. In fact, there are 2 such intersections. If we produced either of those 2 public good levels, we would have no private goods left to give to individual 1, because all the private goods are used to produce public goods and to give private goods to individual 2 in order to get that individual to the magenta utility level. But if we produce a public good level in between the intersection points of the magenta indifference curve and the green production possibility frontier, we will have private goods left over for individual 1 after we give individual 2 enough private goods to get him to the utility level U2 bar. In fact, for any public good level in this range, the vertical distance between the green production possibility frontier and the magenta indifference curve is how much in private goods we'll have left over to give to individual 1 once we've given individual 2 enough private goods to get him to the magenta indifference curve. In panel C, we'll then draw how much in private goods we'll have left after getting individual 2 to the magenta indifference curve for different levels of public good production. For any public good level between Y lower bar and Y upper bar, the vertical distance in the green shaded area is equal in panel C to what it was in panel B. Given that we guarantee individual 2 the utility level U2 bar in panel B, efficiency now requires that we choose a public good level in panel C that will maximize utility for individual 1. If we do so, we'll have reached a situation where we can't make one person better off without making anyone else worse off, which is the definition of an efficient allocation. The efficient level of the public good will then appear as a tangency between a blue indifference curve for individual 1 and the constraint that gives us how much in private goods we actually have left over for different quantities of the public good once we've gotten individual 2 to her utility level U2 upper bar in panel B. At this tangency, the slope of the green constraint is equal to the slope of the blue indifference curve. The slope of the blue indifference curve is simply the marginal benefit that individual 1 gets from one more unit of the public good. And the slope of the green constraint arises from the way we've constructed that green constraint. Recall that it emerged when we subtracted the magenta indifference curve in panel B from the green production possibility frontier in panel B. The slope of the green production possibility frontier is minus the marginal cost of the public good, and the slope of the magenta indifference curve is minus the marginal benefit that individual 2 gets from public goods. When we subtract the magenta indifference curve from the green production possibility frontier, the slope that emerges in panel C is the slope of the green production possibility frontier minus the slope of the magenta indifference curve. In other words, minus MCY minus a negative MB2, which becomes minus MCY plus MB2. Starting with the equation that appears above the tangency in panel C, we can now add MB1 to both sides and add MCY to both sides, and we'll get the equation that MB1 plus MB2 is equal to MCY. In other words, the sum of the marginal benefits for the public good has to be equal to the marginal cost of producing the public good at the optimal public good quantity Y star. This is, of course, precisely the intuition we first got from graph 27.1. When we deal with public goods, where everyone can consume the public good at the same time, efficiency requires that we produce where the marginal cost is equal to the sum of the marginal benefits. It may seem strange that in panel B we chose some arbitrary level of utility to guarantee individual 2, but we could have chosen any other arbitrary utility level for individual 2 and followed the same reasoning to come to the same conclusion, that any optimal solution to the public goods production problem will require that we'll produce a public goods level such that the sum of the marginal benefits will be equal to the marginal cost.